Hi, my name is Omer Ozaran, and this video is for Data698, and this project is data collection analysis. For data, I use it from UCI Machine Learning Repository, and my current data actually has over $100,000 observations and then 50 columns, and there are 43 columns that actually have no missings, meaning that I do have 7 or more columns that I have to use some imputation techniques. And when we look at the data distribution, I see that over 94% were not readmitted, and then 6% are readmitted. So it's basically pretty much imbalanced data, whereas not admitted people, minority, and then actually admitted people are minority, and not admitted people are majority in our target data, which is called rate admitted. So the next thing that I show is basically data description. There are couple variables that I want to show and discuss, and for example, race, gender, age, weight, and a target in hospital. And then we do have a rate admitted. This is our target data, and then it's category of data, and we can see that description is a true and false, and then we convert that 0 and 1. One is basically it's readmitted less than 30 days, and then not readmitted it's a 0. And when we look at it, our summary is a 6-6. Basically, as I said earlier, we all have over 100,000 records and 50 features, and there are a lot of variables. There are 7 or more variables that actually has a missing values. When we look at the missing values, we can see that here we do have the graph that shows that the highest missing value column name is its weight, and then we do have medical specialty, which is 50% of them is the missing. And then when we look at the diabetes medicines, 0.51%, and the payer code is 39%. So there are actually variables that actually exist that has a lot of missing values. And also when I look at the occurrences and then I look at some statistical results, I see there's some medications, for example, metformin and pioglitazone and gliproprotein, and they're highly skewed. And then there are some encounter ID, and then when we look at the encounter ID, there's a high mean value and a median value for those variables. And when I move forward to combinatorial modeling data, the first thing that I did basically the cleaning the data. So I dropped a couple columns that has a lot of missing values in there. And also I use the near zero variances. That actually looks at each column and it shows me if there's any change in the values. If there's no, you can put it to the threshold, 80%, 90%, the value is not changing, you can drop that column. And then I use for that, I drop the column that actual values are not changing too much. And then, like I said, there are a lot of variables that actually has a lot of missing. I drop those too. And, when we look at the counter ID, patient number, weight, prayer ID, prayer code, those are the one that has a high missing values. And then there's a gender column that I assume that I can't put the mean value or put some different value on that to imputation. So I will be dropping the gender column for our modeling purposes. So there are a couple columns that I use an encoding, meaning that I change the string values to the category values. For age, actually I use the mean values, and you can see that right here for target exactly rate admitted. So no rate admission 0, rate admitted is basically is equal to 1. You can see a couple medications are in string values. I changed them that category values, and then race, I change the category value, gender, I change the category values here. And then when we look at the correlation between the top 10 variable, we can see that here some of them are negative correlated, and then some of them positive related to each other. and I'm here listing basically top 5 variables that correlated positive, and then top variables that actually negatively correlated here. The next thing that I'm looking at basically distribution of our target variables. We can see that over 94,000 people actually cases that not readmitted, and then over 6,000, which is a 6% of readmission rate right here. It's a pretty imbalanced the data. And then the next thing that I'm looking at, basically looking at the distribution of the features that we're going to be using for modeling purposes. And you can see that some of them is skewed. We can see that right here, and the age, how it looks like, and then in timing in a hospital. All each variables presented different distributions. And next thing that I want to look at that is basically, is there an outlier? The data actually not perfect, and then there are some variables that shows the outlier, but most of the variables that I have is category variable, meaning that they have either 0 values and 1 values, because I use an encoding for that reason. And then this is what this shows right here. And then when I look at the relationship between the target and explanatory variable, you can see that how they are related to the target. So among all the 23 the predicted variables after cleaning and encoding, we started with the 50, and then we dropped the sum of them in purpose of the cleaning. And majority of them have a clear association with the target variable. Maybe half of these predictors, if they're numerical and continuous, have a clear relation to the target in a linear relation. So when we use a classification model, and classification model actually trying to understand what's happening in readmission by looking at these variables here. And when we look at the data visualization, I want to see that how age is distributed by looking at the readmission. We can see that right here, how the box plot looks like it, and then how the age is distributed by looking at the readmission and not readmitted. And we can see that right here, admission type in the same deal. And then next one is a discharge disposition ID. I can see that how disposition ID looks like in readmission, and a time in a hospital, and I can look at it the days time in a hospital right here, how it's distributed by looking at the disk graph right here, and then I do have a box plot for that. And then admission source ID in the same day right here. I can see that there are some skewness here actually, and then I can look at the number of lab procedures, and then I can see it right here, the box plot, and then I do have actually the values that how it looks like in readmission status here. And then I do have a gender. How the gender look like? You can see that we actually use a 0, 1 here, and then that's the reason you're not seeing anything between the two values here. We can see that how the gender looks like in readmission and then not readmitted. And then when we look at the race, it's exactly the same thing. 0 presented black, and then 1 presented white, Caucasian, and also 1 right here. And then we have all the distribution. And also I do have entire code that is here, and also I will submit that. Thank you so much.